Hello students, welcome to Future Dr. NEET Academy for the crash course in NEET Physics. Topic today is from chapter 11, Dual Nature of Radiation and Matter. This is the from 12th standard topic, Dual Nature of Radiation and Matter. Let's move to the topics. That is, thermionic emission. Electron emission may be classified into two, thermionic emission or field emission. Thermionic emission, the process of emission of electrons when a metal is heated is known as thermionic emission. Emitted electrons are called thermions and emitted number of thermion depends on temperature of metal surface. Fission emission, the process of emission of free electrons when a strong electric field of the order of 10 power 6 volt per meter is applied across the metal surface is called field emission or cold emission as used in spark plug. Photoelectric emission, the process of emission of electrons when light of suitable frequency is incident on metal surface is called photoelectric emission. And this phenomenon is called photoelectricity. And emitted electrons are called photoelectrons. Number of photoelectrons emitted depends on the intensity of incident light. Secondary emission. What is secondary emission? The process of emission of free electrons when highly energetic electron beam is incident on a metal surface is called secondary emission. The emitted electron is called secondary electrons. Photoelectric effect. The phenomenon of photoelectric emission was discovered by Hertz, and Alvax and Len investigated the phenomenon of photoelectric emission during 1886 to 1902. Certain metals like zinc, cadmium, magnesium, etc. only responded for UV light, that is ultraviolet light, which causes photoelectric emission. However, some alkali metals like lithium, sodium, potassium, cesium, rubidium, etc. are sensitive with visible light. It means when visible light is illuminated on this material, it emits electron that we are calling photoelectrons. What is work function? Is a minimum quantity of energy required to remove an electron from metal surface is called work function. Is denoted by symbol W or phi will be used. And there are four laws of photoelectric effect, various laws of photoelectric effect. For a given photosensitive material and frequency of incident radiation, that is, it should be above the threshold frequency, then photoelectric current is directly proportional to the intensity of light. This is the first law. So from the graph, what is it? Photoelectric current and intensity are directly proportional, means it follows a straight line curve. Curve obtained is straight line. Second law, for a given photosensitive material and frequency of incident radiation, saturation current is found to be proportional to the intensity of radiation, whereas the stopping potential is independent of intensity. Okay, that is, if you plot a graph, photoelectric current along y-axis and potential along x-axis, then what will happen? For a given intensity, its curve is like this. For I1 intensity, for I2 intensity, second curve, I3 intensity, third curve. Here I3 is greater than, I2 is greater than I1, but VO, that is stopping potential, is constant. VO or V0 is constant. Third one, for a given photosensitive material, there exists a minimum cutoff frequency called threshold frequency, below which no emission of photoelectron takes place, no matter how intensity of light is. Threshold frequency is different for different metals. Above the threshold frequency, the stopping potential or equivalently the maximum kinetic energy of emitted photoelectrons increases linearly with the frequency of the incident radiation, but is independent of its intensity. Next one, The maximum kinetic energy of photoelectrons or stopping potential varies linearly with the frequency of the incident radiation and is independent of its intensity. Last one, photoelectric emission is an instantaneous process. It is a fast process. Einstein's theory of photoelectric effect. Einstein explained photoelectric effect with the help of Planck's quantum theory. That is, when a radiation of frequency nu is incident on a metal surface, it is observed in the form of discrete packets of energy, that is called quanta or photons. A part of energy hν of the photon is used in removing the electrons from the metal surface, and remaining energy is used in giving kinetic energy for the production photoelectron. Then Einstein photoelectric equation is kinetic energy equal to of mv square, that is equal to hν minus hν naught. hν is the energy incident and hν naught only is also called as W naught, that is only work function. If nu naught is the threshold frequency, then that work function W equal to h nu naught. Nu naught is the threshold frequency. Then this equation becomes kinetic energy, that is of mv square equal to hν minus hν naught, h has taken outside as h into nu minus nu naught. And all the experimental observation can be explained on the basis of Einstein's photoelectric equation only. Compton effect or Compton shift. It is a phenomenon of increasing the wavelength of X-ray photon which occurs when these radiations are scattered or striking an electron. The difference in the wavelength of scattered and incident photon is called Compton shift. That is del lambda equal to h by m naught c into 1 minus cos phi. Here phi is the angle of scattering of the X-ray photon and m naught is the rest mass. H is a Planck's constant, c velocity of electromagnetic waves. Dual nature of radiation. Light has dual nature, that is, it manifests itself as a wave in diffraction, interference and polarization like experiment, while it shows particle nature in photoelectric effect, Compton effect, scattering, etc. Dual nature of matter, or called also matter waves. As there is complete equivalence between matter, that is mass, and radiation energy, and the principle of symmetry is always obeyed. That is, de Broglie suggested that moving particle like protons, neutrons, electrons, etc. should be associated with waves known as de Broglie waves, and their wavelength is called de Broglie wavelength. The de Broglie wavelength of a particle of mass m moving with velocity v is given by lambda equal to h by p, or p is mv, h by mv. And substitute, that is kinetic energy equal to half mv square, v equal to root of 2 ke by m. We substitute that, then lambda equal to h by square root of 2mk or 2me. K or E is a kinetic energy. And suppose de Broglie wavelength of electron you want to calculate, then wavelength associated with an electron being accelerated through a potential is lambda equal to h by root of 2mev, and h value 6.6 into 10 power minus 19 divided by 2 into mass 9.1 into 10 power minus 31, and charge of electron 1.6 into 10 power minus 16. Simplify this and finding square root, and by simplifying you will get 12.3 into 10 power minus 10 meter with by root v. So if the question is asked for electron, then lambda equal to 12.3 angstrom divided by square root of v. V is the potential, and de Broglie associated with the particle of momentum p in terms of nanometer means lambda equal to 1.22 root v nm. Here v is the magnitude of the accelerating potential. Yes, this is a Davison-Germer experiment to prove the existence of the matter wave. Here finally you will get a diffraction pattern. Diffraction pattern shows that your wave is formed. So that wave only called as matter wave or de Broglie wave or pilot wave, because this wave only guides the particle to move. Electron microscope. Electron microscope, like optical microscope, is an instrument principally used in the research laboratory for magnifying some object. the wave nature of moving electron on the basis of electron microscope only. Resolving power of a microscope is the least distance between 2 points which can be distinguished. The resolving power of microscope is limited by the wavelength of the radiation used, and in microscope the visible light is used to illuminate the object, and the highest magnification obtained with the best optical microscope is about 2000. Since the wavelength of X-rays is smaller than that of visible light, one can think of having an X-ray microscope. X-rays cannot be focused as visible radiation or focused using lens. But electrons have de Broglie wavelength of the order of X-rays can be focused easily using electric and magnetic field. One can build a high resolving power microscope using electrons. So here instead of magnet, what we are using? Yes, electromagnets are used. For electrons excited by a potential difference of about 60,000 volts, the wavelength is about 5 into 10 power minus 12 meter. This is 10 power 5 times smaller than that of visible light. Yes, the resolving power of an electron microscope will be 10 power 5 times or 10 power 6 times greater than that of optical microscope. This is the diagram for electron microscope. This is a comparative discussion for electron microscope with optical microscope. This is optical microscope and this is electron microscope. It must be kept inside a vacuum chamber. Otherwise, ionized gas or electron may disturb the apparatus setup. Okay. Next chapter, chapter 12, atoms, Anukkal, or atomic physics. Dalton's atomic theory, postulated in 1803 by John Dalton. According to him, all elements are composed of invisible particles called atoms. Atoms of same element are exactly alike and different elements are not alike. Compounds are formed by joining atoms of two or more elements. Next atomic model is Thomson's atomic model, postulated in 1897 by J.J. Thomson. According to him, atom consists of positively charged protons and negatively charged electrons. An atom could be divided into its constituent elementary particle, and atom is neutral. It's electrically neutral. Next, Rutherford atomic model, postulated in 1909, showed that the atom has a nucleus and inside the nucleus are protons and neutrons. Outside the nucleus are the electrons, and discovered that all positive charges are connected to the center of the atoms called molecules by shooting alpha particle through a gold sheet and counting the number of particles that went through. Said the electrons orbit around the nucleus like the planet orbit around the sun. He could not explain why the electrons were not falling into the nucleus. And distance of closest approach formula are not equal to 1 by 2 pi epsilon naught into 2 squared by Ek. R naught is depends upon the initial kinetic energy Ek of the alpha particle. Impact parameter. The scattering angle of the alpha particle impact parameter is related as B equal to Zt square cot theta by 2 by 4 pi epsilon naught Ek. Here Ek is the kinetic energy of alpha particle and Z is the atomic number of nucleus, and smaller the impact parameter, larger the angle of scattering. Rutherford scattering formula. Next, Bohr atom model, postulated in 1913 by Niels Bohr. According to the electrons in an orbit are revolving certain fixed orbit, that is called stationary orbit, for which the angular momentum of an electron is an integral multiple of h by 2 pi or nh cross. Here h is a Planck's constant. The electrons in the stationary orbits do not radiate energy, and an atom may absorb or emit discrete energy photons only when one of the elements of an atom jump from lower to higher energy respectively. Thus, if an electron jump from initial state of energy E1 or EP to final state of energy En. H nu Nm equal to En minus Em. A stable orbits do not emit radiation by acceleration. And electrons revolve around the nucleus in which orbits. Now, radius of the nth orbit Rn is proportional to n square by z. Like this, after some few slides, we are going to see the direct formula for Bohr atom model also. Next, wave model. Based on wave mechanics, propose that electrons do not move in a definite and that the location of electron is based on how much energy each electron contains. Quantum numbers are the numbers required to completely specify the state of the electron. In the presence of strong magnetic field, 4 quantum numbers are there. First one, principal quantum number, n can have value 1 to infinity. Second quantum number, orbital quantum number, orbital angular momentum quantum number, can have value 0, 1, 2, 3 up to n minus 1, and magnetic quantum number m1, which can have values minus L to plus L. And magnetic spin angular momentum quantum number, which can have only 2 values, plus or minus 1 by 2. What is excitation potential? Minimum excitation potential, which provides the sufficient energy of an electron to make a transition from innermost orbit to any one of the outermost, is called excitation potential. And the ionization potential is a minimum accelerating potential, which provides the sufficient energy for an electron just to remove it from the atom, is called ionization potential. And these are the different spectral series. First one, Lyman series, n1 equal to 1, n2 equal to 2, 3. It means there will be a transfer of electrons or energy from outermost orbit, second or third orbit, to first orbit. And the spectrum obtained is in falls in ultraviolet region. Next, Balmer series, n1 equal to 2 and n2 equal to 3, 4. It falls under invisible region. Paschen series, n1 equal to 3, n2 equal to 4, 5, then it is infrared region. Bracket series, n1 equal to 4, n2 equal to 5, 6, and it falls under mid IR region. And last one, Fund series, n1 equal to 5, n2 equal to 6, 7. It falls under far infrared region. Comparative studies of spectral series. That is, lambda Fund is greater than lambda bracket is greater than lambda Paschen, greater than lambda Palmer, greater than lambda Lyman. Maximum number of special lines obtained due to the transition of electron is n equal to n into n minus 1 by L. N is the maximum number of spectral lines obtained. Small n is the number of transition elements. Just to note down this formula, radius of the nth orbit Rn is proportional to n square by z, and velocity of an electron is proportional to z by n, and kinetic energy is 13.6 z square by n square eV. That is total energy. And potential energy 27.2 z square by n square eV, and total energy is minus 13.6 z square by n square eV. From this frequency of electron in nth orbit means this divided by h. Then you will get frequency. Wavelength of radiation in the transition from n2 tends to gives n1 is given by 1 by lambda equal to r into z square into 1 by n1 square minus 1 by n2 square. And here r is a Rydberg constant, that is 1 by 4 pi epsilon naught whole square, 2 pi square me power 4 by ch cube. And its value is equal to 1.09 into 10 power 7 per meter, because here its value is a constant value, it was for many days. Ionization energy, formula 13.6 z square by n square eV. Ionization potential 13.6 z square by n square only. It is in volt. And in quantum mechanics, the energy of a particle of mass m is confined to a box of length L, have discrete value as E equal to n square h square by 8m L square. And here n is the number of quantum numbers or principal quantum number, L is the length of the box. And this ionization energy, excitation energy and all we discussed. Laser maser. Laser means, laser stands for light amplification by stimulated emission of radiation. That is laser. And it is a device. Laser is a device used to produce highly intense, strong, monochromatic, coherent and collimated beam of light. What is monochromatic? Yes? Come on, say, what is monochromatic? Monochromatic is a light source, is a source having single wavelength or definite wavelength. That is monochromatic. Okay. And same way maser. Maser means microwave amplification by stimulated emission of radiation. It's simply a device for producing a highly intense monochromatic